Look up at the night sky, what do you see? Maybe you spot the moon, a few bright stars, or even a planet shining like a steady jewel. But honestly, what you're seeing is just a tiny, tiny piece of something much, much bigger. You are looking out into the universe. The universe is everything. It's all of space, all of time, and everything that exists within them. It includes you, me, the ground beneath our feet, and even the farthest star you can imagine. The universe is the grandest stage we know, a place of incredible beauty, immense scale, and profound mystery. It's the ultimate story and, well, we're lucky enough to be a part of it. Thinking about the universe can make you feel very small, but honestly, it should also make you feel incredibly special. Imagine every single grain of sand on every beach on Earth. The universe has more stars than all those grains of sand. It's vast beyond our everyday comprehension. This immense collection of matter and energy isn't just empty space with a few things scattered about. It's a dynamic, changing, and interconnected system. Every atom in your body was forged in the heart of a dying star billions of years ago. We are, in a very real sense, made of stardust. We are the universe's way of knowing itself. So, what does it mean to explore this cosmic ocean? It means asking the biggest questions we can think of. Where did all of this come from? Are we alone? What is our place in this grand cosmic ballet? For millennia, humans have looked up at the stars and wondered. We told stories about them, navigated our world by them, and dreamed of one day reaching them. Today, we do more than just dream. We build powerful telescopes and send robotic explorers out into the void. We are on a great journey of discovery, peeling back the layers of the cosmos, one mystery at a time. This journey isn't just for scientists in white lab coats. It's for everyone. The story of the universe is our shared story. It's a story of origins, a story of evolution, and a story of our possible future. As we travel through this essay, we'll embark on our own small voyage. We'll visit the stars, journey to distant galaxies, and even travel back in time to the very beginning of everything. So buckle up. The cosmos awaits, and it has so much to show us. Let's open our minds and let the universe in all its magnificent and mind-boggling glory. Let's begin our journey with something familiar, a star. Not just any star, but our star, the Sun. The Sun is a massive ball of incredibly hot gas, mostly hydrogen and helium. It is the heart of our solar system. Its immense gravity holds everything in our cosmic neighborhood together, from the smallest asteroid to the largest planet. The Sun provides the light and heat that make life on Earth possible. Without it, our planet would be a frozen, dark, and lifeless rock. Every time you feel the warmth of the Sun on your skin, you are feeling the energy created by nuclear fusion happening 93 million miles away. Orbiting our Sun are the planets, including our home, Earth. A planet is a large celestial body that orbits a star. Our solar system has 8 of them. The 4 inner planets, Mercury, Venus, Earth, and Mars, are rocky worlds. They have solid surfaces you could, in theory, stand on. The 4 outer planets, Jupiter, Saturn, Uranus, and Neptune, are gas giants. They are huge worlds made mostly of gas and liquid with no solid surface to speak of. Each planet is a unique world with its own weather, its own moons, and its own secrets waiting to be discovered by our robotic emissaries. But planets and stars are not the only things in our neighborhood. There are also moons, which are natural satellites that orbit planets. Earth has one big moon, but a giant planet like Jupiter has dozens of them, some of which are worlds in their own right, with ice shells and potential subsurface oceans. There are also asteroids, which are giant space rocks left over from the formation of the solar system, mostly found in a belt between Mars and Jupiter. And then there are comets, the dirty snowballs of the cosmos, which are icy bodies that develop long, beautiful tails as they get closer to the Sun. All of these objects, our Sun, the 8 planets, all their moons, and the countless asteroids and comets, make up our solar system. It is our home, our little corner of the cosmos. But as vast as it seems to us, our solar system is just one of billions in our galaxy. It's like finding your house on a map of your city. It's important and it's where you live, but it's just one small point in a much, much larger picture. To understand the universe, we have to zoom out and see the bigger structures that hold everything together. If our solar system is like a single house, then our galaxy is the city it belongs to. A galaxy is a huge, gravitationally bound system of stars, stellar remnants, interstellar gas, dust, and dark matter. The galaxy we live in is called the Milky Way. It is a beautiful spiral galaxy shaped like a giant spinning pinwheel. Our sun is just one star among hundreds of billions of other stars in the Milky Way. When you look up at the night sky and see that faint milky band of light stretching across it, you are looking into the crowded center of our own galactic city. All the stars you can see with your naked eye are part of the Milky Way. But our galaxy is not alone in the universe. It is just one among an estimated 2 trillion galaxies. 2 trillion. That number is so large it's hard to even imagine. Each of those galaxies is an island universe, a city of stars separated from its neighbors by vast stretches of nearly empty space. Some galaxies are spirals like ours. Others are smooth and oval-shaped, called elliptical galaxies. And some are small and have no regular shape at all, known as irregular galaxies. Each one is a cosmic metropolis with billions or even trillions of stars. Galaxies are not just scattered randomly through space. They are organized into even larger structures. Just like cities are grouped into countries and continents, galaxies are grouped into clusters. Our Milky Way is part of a small group of about 50 galaxies called the Local Group. Our nearest large neighbor is the Andromeda Galaxy, another beautiful spiral that is even bigger than our own. It's so close that on a clear, dark night, you can see it as a faint, fuzzy smudge of light. It is the most distant object you can see with your own eyes. Andromeda is currently hurtling toward us at a speed of about 250,000 miles per hour. But don't worry, the cosmic collision won't happen for another 4.5 billion years. When they do merge, they will form a new, giant elliptical galaxy. This dance of galaxies, this constant movement, merging, and evolution happens all across the universe. It is a beautiful and powerful reminder that the cosmos is not a static, unchanging place. It is alive, dynamic, and constantly being reshaped by the fundamental force of gravity on the grandest of scales. So where did all of this, the stars, the planets, the trillions of galaxies, come from? How did our universe begin? The best scientific story we have for this is called the Big Bang Theory. This isn't a story about an explosion in space because space itself didn't exist yet. Instead, it is the story of the beginning of space and time. It tells us that about 13.8 billion years ago, the entire universe, everything we can see and everything we can't, was compressed into an incredibly hot, incredibly dense single point. A point smaller than a single atom. From that initial state, the universe began to expand. It was not an explosion into pre-existing emptiness. It was the expansion of space itself, everywhere at once. In the very first fractions of a second, the universe was a searingly hot soup of fundamental particles and energy. As it expanded, it began to cool down. This cooling allowed the basic forces of nature to separate, and for the first stable particles like protons and neutrons to form. For the first few 100,000 years, the universe was still so hot and dense that it was opaque, like a thick fog. Light could not travel freely. Then, about 380,000 years after the Big Bang, the universe cooled enough for protons and electrons to combine and form the first atoms, mostly hydrogen and helium. At this moment, the universe suddenly became transparent. Light was finally set free to travel through space. We can still see the faint afterglow of this moment today. It is called the Cosmic Microwave Background Radiation, or CMB. This ancient light fills the entire universe, and it is the oldest light we can ever see. It is a baby picture of our universe, a fossil from its earliest moments. This simple beginning, a hot, dense state followed by expansion and cooling, set the stage for everything that followed. The universe started with almost nothing but hydrogen, helium, and the laws of physics. But that was enough. Gravity, the great sculptor of the cosmos, began to pull these simple elements together. Over millions and billions of years, it would gather the gas into giant clouds, which would then collapse to form the first stars and galaxies. The story of the universe is a story of how, from a simple hot beginning, an incredible and complex cosmos could emerge. So, the Big Bang wasn't just a one-time event that's now over. The expansion that began almost 14 billion years ago is, actually still happening today. Every galaxy is, on average, moving away from every other galaxy. It's kind of like baking raisin bread. When the dough rises and expands, every raisin moves farther away from every other raisin. But the raisins themselves aren't moving through the dough. It's the dough itself that's expanding and carrying them along for the ride. In the same way, galaxies aren't really flying through space away from each other. Space itself is stretching, and it's carrying the galaxies with it. For a long time, astronomers thought this expansion might be slowing down. They figured that the gravity from all the matter in the universe would sort of act like a brake, pulling everything back together. Some even wondered if the expansion would eventually stop and reverse, leading to what they called a big crunch, where the universe would collapse back in on itself. It was a reasonable idea. After all, if you throw a ball into the air, Earth's gravity slows it down and pulls it back. Why wouldn't the gravity of all the galaxies do the same thing to the universe's expansion? But then, in the late 1990s, astronomers made a really shocking discovery. By observing these very distant exploding stars, called supernovae, they found that the expansion of the universe isn't slowing down at all. In fact, it's actually speeding up. The universe is accelerating its expansion. This was a complete surprise, and honestly, it's still one of the biggest mysteries in science today. Something is pushing space apart, overpowering the pull of gravity on the largest scales. This mysterious force or energy has been given a name: dark energy. We don't know what it is, but it seems to make up about 70% of the entire universe. This discovery really changes our understanding of the universe's ultimate fate. If this acceleration keeps going, the future will be a very different place. Over trillions of years, all the other galaxies will be pushed so far away from us that their light won't even be able to reach us anymore. The night sky will eventually become dark and empty, with only the stars of our own merged Milky Way Andromeda galaxy left visible. The universe will become a cold, dark, and lonely place. This continuing expansion is a fundamental part of the universe's story, a story that's still being written across the fabric of space-time. Section 6. The human thirst for knowledge. Why do we spend so much time, effort, and money to explore space? We can't live there, and it doesn't immediately put food on the table. The answer is simple and profound. We are curious. It is a fundamental part of what makes us human. From our earliest ancestors who looked up and tracked the seasons by the stars, to the modern scientists who build giant telescopes, we have always had a deep desire to understand our place in the cosmos. We want to know where we came from, what the universe is made of, and if we share this vast existence with other life forms. This drive to explore has always pushed us forward. When ancient Polynesian navigators sailed across the vast Pacific Ocean, they were not just looking for new islands. They were pushing the boundaries of their known world, driven by a spirit of discovery. Exploring space is the modern equivalent of that great age of exploration. The planets, moons, and stars are our new, undiscovered continents. The challenges of space travel force us to be innovative, to invent new technologies and solve incredibly difficult problems. This push for innovation often leads to amazing benefits right here on Earth. Many of the technologies we use every day were originally developed for the space program. GPS navigation, which helps us find our way around town, relies on a network of satellites. The camera in your phone is a direct descendant of the small, high-quality digital imagers created for space missions. Medical imaging like CAT scans and MRIs, materials for firefighter gear, cordless power tools, and even improved baby formula have all come from research aimed at sending humans and robots into space. Exploring the cosmos is an investment in our own future, driving scientific and technological progress that improves life for everyone. But perhaps the most important reason we explore is for perspective. When we see a picture of Earth taken from space, a pale blue dot hanging in the vast darkness, we are reminded of how precious and fragile our world is. From space, there are no borders, no divisions between nations or peoples. There is only one Earth, our shared home. Space exploration has the power to unite us, to give us a common goal, and to inspire us to take better care of our planet and each other. It reminds us that we are all crew members on Spaceship Earth, traveling together through the cosmic sea. Section 7. Our cosmic postcards, discoveries from afar. Our exploration of the cosmos has sent back some incredible postcards. We have sent robotic landers to the surface of Mars, which have roamed its rusty red deserts for years. These rovers have shown us that Mars was once a very different place, We have found evidence of ancient riverbeds, deltas, and lakebeds. This tells us that billions of years ago, Mars had liquid water flowing on its surface, and where there was water, there might have been life. The search for past or even present life on Mars is one of the most exciting quests in science today, all thanks to our robotic explorers. We have also sent probes to the outer solar system, to the giant gas planets and their many moons. The Voyager spacecraft, launched in the 1970s, gave us our first close-up views of Jupiter's Great Red Spot, a storm larger than Earth, and Saturn's magnificent rings. More recently, the Cassini mission spent over a decade orbiting Saturn, revolutionizing our understanding of it. Cassini discovered geysers of water ice erupting from the surface of Saturn's small moon, Enceladus. This suggests there is a liquid water ocean beneath its icy shell, making it one of the most promising places to search for life beyond Earth. Beyond our solar system, our telescopes act as powerful time machines. Because light takes time to travel, when we look at distant objects, we are seeing them as they were in the past. The Hubble Space Telescope has given us breathtaking images of star-forming nebulae, the beautiful clouds of gas and dust where new stars are born. It has also stared deep into space to capture images of the most distant galaxies, showing us what the universe looked like when it was just a fraction of its current age. These deep field images revealed a cosmic zoo of galaxies in all shapes and sizes. More recently, the James Webb Space Telescope has pushed our vision even further back in time. By looking at the universe in infrared light, it can see through dust clouds and peer back to the cosmic dawn, the era when the very first stars and galaxies were forming. It has already discovered galaxies that are older and more developed than we thought possible, challenging our models of the early universe. Every new discovery from these incredible instruments doesn't just answer old questions, it gives us a whole new set of even more exciting questions to ask. Section 8. Strange and Wondrous Facts from the Void. The universe is not only vast and old, it is also incredibly strange. It is filled with objects and phenomena that defy our everyday experience. Take neutron stars, for example. These are the collapsed cores of massive stars that have exploded. They are so dense that a single teaspoon of neutron star material would weigh more than all of humanity combined. They are like city-sized atomic nuclei, spinning hundreds of times per second. They are one of the most extreme forms of matter in the entire universe, a true cosmic wonder. Then there are black holes, perhaps the most famous and mysterious objects in space. A black hole is a region of space-time where gravity is so strong that nothing, not even light, can escape. They are formed when the most massive stars die and their cores collapse under their own gravity without stopping. We cannot see black holes directly, but we can see their effects on the stars and gas around them. At the center of our own Milky Way galaxy lies a supermassive black hole named Sagittarius A*, that has a mass of 4 million suns. The universe is also filled with things we cannot see at all. We already mentioned dark energy, the mysterious force causing the universe's expansion to accelerate. But there is also dark matter. When astronomers look at how galaxies spin, they find that they are spinning too fast. There is not enough visible matter, stars, gas, and dust to provide the gravity needed to hold them together. There must be some other invisible matter providing the extra gravitational pull. We call this dark matter, and we believe it makes up about 25% of the universe. We know it's there, but we have no idea what it is made of. Even time itself behaves strangely in the universe. According to Einstein's theory of relativity, time can be stretched and squeezed. The stronger the gravity, the slower time passes. This means that time actually passes slightly slower for someone on the ground floor of a skyscraper than for someone on the top floor. This effect is tiny on Earth, but near a massive object like a black hole, it becomes extreme. This idea, called time dilation, is not science fiction. It's a proven fact of our universe. The cosmos is a place where the rules of reality are pushed to their absolute limits. Section 9. Our future in the cosmos. Our journey through the cosmos brings us back home, to our own small world, but with a new and expanded perspective. We have learned that we are part of a vast and ancient story. A story that began 13.8 billion years ago and is still unfolding all around us. We are made of stardust, living on a tiny planet in a typical solar system, which is part of an ordinary galaxy among trillions. This knowledge can be humbling, but it is also empowering. It connects us to everything else in the universe and gives our lives a cosmic context. The exploration of the universe is one of the noblest and most unifying adventures humanity can undertake. It calls upon the best of our nature, our curiosity, our intelligence, our creativity, and our courage to face the unknown. The challenges of space exploration will continue to drive innovation, creating new technologies that will help us solve problems here on Earth, from climate change to resource management. The search for life elsewhere will force us to think deeply about what it means to be alive and what our responsibility is to the life on our own planet. The future of humanity may very well lie in the stars. As we continue to develop our technology, we may one day become a multiplanetary species, with settlements on the Moon, Mars, and perhaps beyond. This would not only be a great adventure, but also a crucial insurance policy for the long-term survival of our species. The universe is full of dangers, from asteroid impacts to stellar explosions. Spreading out into the solar system would ensure that no single event on one planet could end the human story. But whether we travel to the stars ourselves or continue to explore them with our robotic eyes and ears, the quest must continue. The universe is the ultimate book of knowledge, and we have only just begun to read its first few pages. There are still so many mysteries to solve. What is dark matter? What is dark energy? Are we alone? Answering these questions will tell us more about the universe, but more importantly, it will tell us more about ourselves. The desire to explore and understand is what makes us human, and the cosmos is the grandest arena for that quest.